Hello, my name is Narayan Gupta, and I'm from the University of Maryland at undergrad.
I'm Angad. I'm from Johns Hopkins, and today we're presenting our research on topic temporal analysis on topics using Word2Vec.
So to outline the motivation of our study, there are many Americans that live in nursing homes, and on top of that live in assisted care. And with those nursing homes, there are many reports that come out on the quality of their service and how people feel about the certain policies they use in those nursing homes, etc. Where there's a lot of vast amounts of text that needs to be analyzed to understand what's going on in them, if there's any mistreatment, etc. And for our task, what we wanted to do was to be able to understand what's going on in this large amount of text and be able to make dashboards to improve decision making for policymakers that review these texts and don't have to read through everything single one by one and have a better tool to understand what's going on with the data. So in general, this is kind of like related to topic modeling, and because we wanted to understand how words are used over time. And the traditional way that we understand how words are evolving is through stochastic counting, but this wouldn't work for this because we want to understand the semantic evolution of words over time as well. So in this study, we go over a new way to extract this information and then be able to visualize how a word changes over time. So to reiterate, this obviously falls onto some traditional topic modeling that has been done before using methods such as LDA. We also utilize semantic models to understand the meaning of a word in a numerical sense and then be able to use it to understand what's happening to it over time. And then also there's other work that's been done on it using n-grams in topic modeling that also again is similar to the stochastic methods that already exist. However, we expand upon it by being able to involve semantics. So there's a background. So in this study, we wanted to be able to create something that not only is allowing you to see how these topics evolve, but being able to see how they change semantically over time. So we wanted to create a user-centric approach where users can select what they want to study and be able to select what words they want to see and how they change over time. So in our framework, a user can select the words they want to see and see how they're changing over time on a selected corpus on different time slices. And one main component of our study is the Word2Vec framework, which allows us to create word embeddings that are trained on a specific corpus that you would select that allows us to capture semantic meanings in our words. So since we are able to capture the semantic meaning, we now have a numerical representation of words in a certain context. And since now we have a numerical representation, we can do a lot more with it rather than just having a word that we look at and seeing how many times it appears in the document. So now with this information, we can understand how a word is related to something or related to another word or if it's not. And you can see that through certain metrics that allow us to see how words are similar semantically or if they're not similar in that provided context in our corpus. This would kind of outline an example of that. So imagine the left picture is one snapshot of like data in 1 month where you have vector A and B, which are two separate words, and they are this like distance away from each other in some embedding space. And this is a 2D representation, but this in practice would be whatever n dimensions that you train your embedding on. And in a different snapshot in the same corpus where you have text from a different time period, these same words diverge and they have a larger distance between them, which shows us that the meaning of these words also changed over time in the text that we're studying. So this outlines the way we are able to track the way words change over time in our methodology.
So I know we just had lunch and this is the last presentation. So just by a show of hands, is everyone with me here? Nice, nice, I love it. So alright, so we're gonna get a little bit deeper into the methodology, how we exactly got here. It's a little bit like detail heavy. So I'll try to go over a little bit like broader brushstroke so that we can leave some time at the end for like a discussion. So basically, we took our data set. It's a large data set that has a temporal component to it, which means that there is some way that we can tell that which time period does this document belong to. We split that data set by some arbitrary size. It could be either model size, it could be either by text size, like dividing the text amount of like certain chunks of data, or it could simply be dividing the text in terms of the amount of time that passed. So like a year, a month, a couple of months, or even days. Now, once these embeddings are generated from these specific slices, we use Word2Vec to capture the semantic relation between them. Finally, we get the distances between two vectors that represent the meaning between them. So a very famous example is king minus queen plus man equals woman. So this is a very famous example in Word2Vec where it showed that adding or subtracting the numerical representation of words can actually lead us to another representation that kind of makes sense, right? So first, as I just said, we split our data, we create our Word2Vec embeddings, we derive the trend data, and finally, using cosine similarity and a few other methods, we get trends. So coming on to trends. So I kind of just want to show what trends actually look like. So this is our base term here, unofficial, and we have taken our relative term as CDC. So we can see how this graph goes from up to down. And if you'll see closely at the x-axis, it's January 20th to December 21. So our corpus, it like starts considering words after they've been in the corpora at least 5 times. So once the model sees a word 5 times, it starts considering it. So as you can see, all of this data was scraped from Twitter, back when Twitter API was still a thing. So one person got it. And so during January of 20th, we can see that there isn't even like 5 mentions of CDC. Whereas June 20th, we start getting something. So for this representation, the higher the value, the further apart the words are. But further on in the demo, when I'll show you, it's the opposite because I thought it'd be much more intuitive to show higher because that's just like human beings are wired, I guess. So we can see June 20th, the term unofficial and CDC are further apart because the value is higher. And we can see that as time progresses, they become more intertwined with each other. Meaning that the corpora shows that people associate these words more closer to each other. So this is something that we were doing to show how disinformation and also the anti-vax movement was taking a hold in online spaces especially. But obviously, you should take this with a grain of salt because these are relative distances, and especially when you're using Twitter data, which can have sarcasm, errors, mistakes, so on and so forth. You want to be careful with what derivations are coming out of your data. So coming back to how we got here, we use a simple Django server and we process our interface beforehand. So we get our data, we slice it, process it, and store our key value vector pairs in a Word2Vec model so that we can have faster inferencing in real time. After that, we have a web interface integrated into it that everyone can use, and like it's pretty intuitive. We also have a reverse term search query that once you generate trends, you can also put the same words back in and see a couple of documents where these terms kind of show up together. So you can kind of guess what they talk about, what they mean, what they don't mean. Finally, putting all of this together, our data processing pipeline is done beforehand, and then our backend and front end use these models to show how our project functions. So we kind of, for a larger data set, we use around 21,000 documents, which is the old age nursing home data set. Basically a data set of all the reports of nursing home all across America. The vector sizes are around 100. Newer, larger models like OpenAI like 3.5 at least use like 1700 or something embedding space. So comparative to the newer models, our embedding space is much smaller because when we create these Word2Vec models, especially on slices, they are much smaller than even the original database that we're splicing from. Our window size is 5, which means we consider 2 words in the front of whatever word we're considering and 2 words behind to get these values out. Usually it's a hyperparameter which can be tuned, so you can have it higher or lower to see what fits best for your use case. And there are 2 Word2Vec architectures, skipgram and Bago words. I won't get into it, but if anyone wants to talk more, I'll be right here after the talk. So now once we started creating these trends, we could see that now we could actually create multiple trends and lay them on top of each other. Because they're relative to each other, these trends, we need to have an anchor point, like a measuring stick, to see how far away they are from each other. Because independently, they don't make much sense because they're initialized randomly in the model. So we can see that even the base term of trust follows quite the same trajectory as unofficial. It's because Twitter itself, as many of you would have guessed, is like split into 2 halves, right? As we all are. So, but the interesting part is that a normal document counting structure, that's something that Google uses for its n-gram count. So if you would go search for Google Books, they have a huge data set of millions of books that they have transcribed and put online, trained n-grams over it, and counted how many words occur how many times, and they show trends on the basis of that. So they're stochastically counting how many times a word comes up, right? So some of the weird things that pop up is that you'll see like 1700s, the occurrence of the word bruh, which is weird, but actually what happens is these old books are actually transcribed from OCR images, and there can be a lot of problems when you scan these images and upload them. So even if there were problems in our data set, seeing the kind of words that follow before and after a certain word tells us more about what the meaning of that word is. So yeah, this is just like some more text that I talked about. So now we wanted to come to a much more broader conclusion that we could see that it's something, but we didn't have like evidence or proof that it's actually something that gives us empirical results. So we wanted to put our methodology on some kind of data that is reproducible and has some sort of periodicity. So the example that we chose was the Olympics. The Olympics happened in 2016 and they were supposed to happen in Tokyo in 2020, but they were pushed to 2021 because of COVID. So we trained our model on 3 sets of years, 2016, 2017, and 2021. And we want to move away from the Twitter data because of the noisy nature of it. We instead chose to scrape the 20 news groups dataset as well as add some text from the New York Times to add high quality data that we can empirically be sure that follows the same kind of structure and format. So we can see in this graph that I've taken like every couple of months from Jan 16, March 16, July 16, September 16, and December 16. This is not just 1 month, it's like a couple of months around them. So you can guess like around 3 months. So 3 months worth of data is just one splice, which is then used to train Word2Vec models on it. Now we keep our base term as the Olympics. And we have a couple of relative terms: track, football, tennis, gymnastics, and race. Because this is a dataset that mostly contains US news, football here means American football. I showed this in Greece this summer for a conference. They didn't like that. And so we can see very clearly that around July 2016, when the Olympics actually happened, we see a huge convergence in all the sports that were in the Olympics. So we can see everything other than American football shows convergence, and American football more or less remains the same. So now how do we disprove this? Same experiment, but 2017. We see all of these terms following different trends. Like they can make sense with each other, they cannot make sense with, like sometimes they don't. But what we do see is the absence of the convergence of all of these terms. But how do we know that we were first the correct time and not a fluke? So we ran it again in 2021 and we see the convergence again. But if you see the graph closely, they're not exactly the same, meaning it's not stochastically counted reproducing the same results, but actually there are different trends which show the same sort of nature with each other.
So yeah, through this study that we've done, we understand how we can measure trends through these numerical representations of words at different timestamps in a context of a corpus, and understand what is going on with that word. As we saw with COVID, for example, you can see that the way the words are being used with each other with unofficial and the CDC, you can see how the sentiment of people can be seen in the semantic embeddings, where people started, the anti-vaccine movement and stuff. It's reflected in our analysis of these trends. These trends can be uncovered in a corpus that you may not know about, and this tool can be used to understand what people are saying in a certain group of texts, whereas where we studied things where we knew what could happen, and we understand that, yes, these things are being reflected in these semantic embeddings that we are creating. So this method allows us to not only analyze this, but also now we can visualize these trends and be able to see what's happening over time in a corpus. And one thing that we do have an advantage in comparison to other methods is that we're able to visualize trends compared to each other. We're able to track other words in relative to each other, rather than where other methods are only focusing on a singular keyword and how it's behaving on its own. Here we can compare them in respect to each other in a large embedding space and through cosine similarity, and see how semantically things are changing. In the future, we would like to use better technologies, right? So when this was made, there's no ChatGPT. We just use Word2Vec, right? So there are better ways to create embeddings now. There are better methodologies for deriving these semantic meanings that we did through this method. And applying that, we can perhaps see what better results we can obtain from a better way of training, right? And on top of that, we can enhance this framework by being able to add other topic modeling frameworks such as LDA or topic2vec that could also aid with this to help people understand what's going on in their corpus with how words are evolving or how topics are evolving. And yeah, that's our presentation. And for now, we're gonna continue to a demo of what we've created.
Yeah, so before we go to the demo, I think I forgot one slide because it's like flying past through all of them. Just one more thing I want to touch upon. So hierarchical trends. So one interesting property that we observed when we started using these models was that you could not only figure out the trends between a single corpus, but you could see inter and intra-cluster trends. What I mean by that is you can have a base term of sports, and you can have relative terms of tennis, track and field, American football, cricket, whatever. You can get trends out of these, how these terms function in relation to each other and the base term itself. But then what you can also do is for the same corpora, you can also have your base term as tennis and your relative terms as Roger Federer or Nadal, and see how they function separately. So we see trends that form as a corpora moves itself, and we also see how trends form, how a part of a corpora changes over time. So continuing from this, I would just take 5 seconds to start our Django application. Between that period, I would want to open the floor for questions as well as a discussion. Anything you guys want to suggest, anything that any person in this room thinks that is a good point, I would love to hear it. So please.
You go ahead.
I'd love to see this done on buzzwords in data science, big data,
AI, Gen AI.
Yeah, what do those do over time?
Yeah, no, that would definitely be interesting because, you know, we were actually discussing this with someone outside. The word gaslighting, for example, it's changed meaning over time. You know, 20 years ago, it would literally mean lighting gas or something. I don't know. But gaslighting now is something entirely different. So yeah, definitely, it would be interesting to see how what you point out is kind of like how language is evolving, right? So it'd be interesting to see how people are using language, and I think it would be possible through just studying a social media data set or such thing. And yeah, no, we definitely like to try that. Questions?
So in the first case where you were using Twitter data, thank you. So in the first example you showed where you were using Twitter data, did you consider using some kind of, say, sentiment analysis to like separate out your corpus so that you could actually pick out irony and sarcasm away from, you know, like sincere tweets?
Yeah, so I understand what you're saying. So yeah, that's not something we did. However, that is something you could implement. So like a classification task could help us actually extract genuine data rather than have some things that get mixed up and create noise in our embeddings. So that's actually a good tip for a future thing we can do. Yeah, no, that's a great idea. Thank you for that.
Another question, sorry.
Yeah,
so in your slide where you were showing the Olympics words that were, you know, so I noticed that gymnastics even in 2017 did converge.
Okay.
Do you know if something happened with gymnastics in 2017?
So I think if you think about like how sports are discussed, gymnastics on its own, and correct me if I'm wrong, I don't want to offend anyone, but like gymnastics are usually talked about in an Olympic sense. So I would say I think that's just the way gymnastics is discussed in the news or something, where whenever people are talking about that, it is about the Olympics rather than its own sport. Where like for example, track and field could be discussed on its own in a collegiate sense, where colleges have their track and field teams, and the news is just discussing that. But yeah.
So when you're using smaller data sets, right, a lot of other things come into play because our data set for our initial tests were so small that even like having 2 or 3 terms more or less would change the dynamics of like the position of embedding itself. So gymnastics was like comparatively lesser there in the corpora than other terms, so that's why it showed a little lesser value, because the embeddings can then, if there are less number of terms in a specific data set, the embeddings can sort of like place them much more closer together, because there is like much more space to place them in, right? You can think like if you have this, we use a dimensionality of 100, so think like the dimensionality of 100 is this entire room, but if you have 100 balls, it's much more easier to fit than 1,000 balls, right? So like the Word2Vec model would try to expand those balls out to different areas, right? So that's why I think even a lot of other terms are to come into play, especially when you start working with large corpora. These kind of problems start like going away. Like all of them, these probabilities start becoming much more normalized.
Thank you.
The sarcasm thing actually doesn't bother me because Word2Vec, right, synonyms and antonyms are actually come out pretty close in word, right? You can say either I hated him with all my heart or I loved him with all my heart, but not I ignored him with all my heart. So whether someone is saying, I earnestly trust Dr. Fauci, or I trust that, right? What you're showing is that the concept of trust is tied to him. There was a lot of conversation about that, whether positive or negative. It's all semantically similar.
Yeah, so I think what you pointed out is like we still notice the trend is happening, right? Trust is something being discussed with Dr. Fauci, and at that time, I'm sure we all remember people. I don't know how many people, but people were not trusting him, right? So that, yeah, that's a great point. I think to elaborate on that, if we can differentiate that sarcasm or something, we can get even better trends that we can observe. But yeah, thank you.
Absolutely. I just want to take a time to show the demo itself. So this is kind of what we're looking at right now. So the base term is news, and these are a couple of this is the default 4 relative terms that we've chosen. and their relationship with each other. So as I said, this is the reverse of the graph that I showed. Higher means more similar now. So now we can start playing around with the data. So we have 3 sets of data. This goes from our smallest data set to our largest data set. So this has like an autocomplete built in for like 80% similar words. So we can choose something interesting maybe. And maybe help. So, and now we can see the visualizer update in real time. We see because the model size is so low, and also I think after our initial study, I also got more into normalization techniques. So we see the term variance is not that much because the terms itself don't change, but we still see some like interesting parts come in, like what, why would May would be much more closer to American than threat. I don't know. I guess we could all, it's like all subjective, but also to kind of alleviate that subjectiveness, we also have a reverse term query search, so we can put our same queries here. So these return, this method returns us a couple of documents where like these base term and relative terms come into play. So we can see where and how this model reacts, why it reacts like this, and like what may be the reasons, and then maybe we can come up with our own analyses of why certain ones behave differently than others. Maybe it's now interesting to go to a much larger data set. This is our nursing home reports data set where we use reports from millions of nursing homes that are generated every year. We combine them into so this data set is generated specifically in terms of a model size. So every slice is equal in size to each other, but not time. So maybe views. Maybe you can put doctors. I'm guessing there will be a lot of doctors in old age homes. What else? Like nurses?
Infection.
Infection.
Family.
Family is a good one. Infectious. Infection. Infected maybe. So this takes a while, a little longer than the other models. I don't know if you can tell. I stayed up the entire last night because I saw the Polar's demo, and I was like, maybe I think I should implement this.
Yeah, so that would have not popped up.
Yeah, it would have taken like at least 15 seconds before my all-nighter, but it works. So let's see. So we can see a very interesting trend is that doctors are clearly much more away from abuse than family members and nurses. So better keep your like parents away from them. This is particularly an interesting trend, which I think, I don't know what this means, but it definitely means something. Anything else? So anyone else want to give some examples?
guess my question is, for every one of those time periods, are you training or generating separate embeddings, right? Like,
yes.
So how many? There's like 10 time periods. And
These are 12.
12. So you have 12 separate sets of embeddings or Word2Vec models.
So this goes from 2016 all the way to 2023.
Okay.
So it's a data set that goes from like January of 2016 to maybe I think December of 2023. So it's like it's a large data set over a huge period.
So I guess, is the cosine similarity for one time period, can you compare that with the cosine similarity on another time period? Because there's essentially different embeddings. And
we don't. So we that's where the relative term comes. Sorry, the base term comes in. The base term is the anchor point.
Right.
So we compare the base term of abuse from, like, let's say this time period with the embeddings of doctor and nurses of that time period, and then we draw the lines between individual time periods of how they evolve over time.
Yeah, but then like the cosine distance for the first embedding model between abuse and doctor, and the cosine distance for another embeddings model in a different time period.
Yeah.
Can you compare? Are they like apples and apples, or is it apples versus oranges?
So it depends on the data set. But if your data set is like constrained or structured like ours, so our data set are basically reports, like 20-page long reports that come out of like old age home. So these reports talk about some very specific things like problems or issues that are happening in these places, like who's the advising doctor, what happened with the patient, etc., etc. And there's a very specific format to it. So if the modality is comparable, then you are comparing apples to apples. But especially if you have Twitter data where you have differentiating opinions, differentiating language. Some people are talking in like different languages. Some people are talking in slang. So this is where like things get a little murky. Right? But if you have if your data structured, these start making more sense. Any other question? Anything that anyone wants to suggest? Yeah, please.
Yeah, I was just wondering how you would, one thing you said was you plan to do this with LDA, and you also talked about hierarchical, you also talked about the stuff you've done with hierarchical findings. So first question is like with LDA, that seems like a more relevant way to find out whether a word belongs to a specific topic or not. Is that the part that you're thinking about?
So LDA, I actually started this research with topic modeling, with LDA itself, and then I kind of like wondered, the question was that how could I get the trends, but not just out of like 5 terms, but like the entire data set itself, like how would it evolve? So LDA is one of the biggest restrictions I felt was that you have to give the number of terms you want to find out. So LDA, for those who don't know, is a topic modeling technique where you apply LDA over a corpus and you get, like you tell it like give me 5 terms, and it gives you the 5 most important terms that LDA thinks is associated with this document. So the thing was, the LDA, you have to give the number of terms, which I felt was constraining, because obviously when you're working with textual data, it's completely arbitrary, completely subjective. So that's where this idea came from. Then I wanted to use LDA for the hierarchical structure, as you said, absolutely correct. So if I want to find the inter and intra-cluster trends, the best way would be for me to find the centroid of a cluster and then use that as a base term to compare the other terms within that. So if you can guess, like Federer, Nadal, tennis ball, all of these words would be close to tennis, or they would be formed around tennis, because they would occur, tennis would occur much more than these terms, and these terms would always occur close to or far by or analogous to or synonyms of tennis.
Yeah, that makes sense. One thing I've done in the past is I've used something like LDA to see how here it's a word, how the word moves away from a specific topic. So let's say at some point Nadal decides to become a politician, so then he gets less and less associated with tennis and more and more associated with whatever party or politics he is in. That might be something more.
Absolutely. So the use cases are quite arbitrary. Like with this research, like to be honest, like even I haven't thought about like the like the nth amount of degree that we can do. So even here at PyData, I met a couple of people. I met people from like VGX, and they were talking about how we can use this financial data and financial modeling. There were people who I met about who talked about, like, obviously, like Twitter data and all these things were a huge part of us. So disinformation and misinformation managing, these were some of the topics that came up. So we are kind of exploring that what we can do, but yeah, this is like very early stages. But like any other ideas would we greatly appreciate. Thank you so much. Please.
You want to wait?
Yeah, I think it'll be better then. I think everyone can hear then.
I'm curious if you're doing anything to offset for just seasonality of frequency. Like, I would imagine gymnastics is always correlated with the Olympics, but because we don't talk about gymnastics in March ever, that's why you don't see the correlation until parents start taking their kids to gymnastics at the end of the school year in June, and all of a sudden we start seeing that. So I would wonder if they're always highly correlated. It's just you don't have any examples in your other data sets or significant data sets to show that correlation. So are you doing anything to offset for frequency in order to show correlation over time?
So one of the biggest problems that we faced was the initialization. The initialization is random, that's why we don't have relative terms, but the initialization also matters every time a new model is created. So every time we are building new embeddings, and embeddings are arbitrary in terms of their meaning and semantics, they capture it, but how they capture it is like completely dependent on them. So what we wanted to do, at least what I thought we could do, is like have a larger model, like the entire dataset, train a single embedding space on it, get all the terms out, fix them, and then fine tune on each of the splices, maybe something like LoRa or adaptive LoRa, like using these low rank matrices, like just train them, so that these terms are at the same, they start from the same space, but according to their corpora, and according to whatever happens in that time space, they change, like they wiggle around a little, so that the dissertation, so that we could actually like account for like extra counting and all. So if we have a single embedding space that we all start from, then we won't not need to worry about the counting issue. Then if like a word is being used more in, let's say, the beginning rather than the end, then it's like then we want that. Then we want to show that okay, this is much more correlated. But so that was my idea. Like, does it make sense? Thank you.
Time is up.
Yeah.
Thank you very much.
Thank you very much. Just 1 second. My colleague Faizan would just like to say a few last words. Thank you so much.
Thank you. Just a quick note I want to mention, the nursing home data set, we're actually using this with respect to, so that data set actually is infection and reports that surveys go to nursing homes across the country, federally owned ones, to basically see what's happening inside those facilities. And one of the things that you've noticed with the examples with COVID and gymnastics is that you have these global phenomena that actually happen. So we want to try to work on being able to identify local events that are happening through statewide. For example, maybe infections spreading through wheelchairs or maybe bed rails and things like that. To identify more of those things happening maybe in the southeast or the northwest, because they may not show up as explicit words themselves. They may be related to different properties. So the hope here is that because we can do these with a global phenomenon, we should be able to also identify them with local events happening statewide. And our company, Explorer Digital, is working on this with the CMS down in the state of Maryland. And so it's a practical application of what we're working on. That's all.
Thank you so much. If anyone of you wants to connect with us, let us know. Alright, we would love to like get to know more about you guys. Thank you.